picking back up in lesson 7-2, and we ended Wednesday by finishing our slope field. Yes? And officially, I don't think I'd written it down or anything yet, but it talks about drawing the particular solution that passes through the point 0, 2. So we're drawing, I better use a different color, a particular solution that goes through that point. What did we decide this is going to be? Yeah, we talked, I think Augie threw it out that he sees a circle here. Okay, so what we're looking at is this is going to be a circle. Now, if we're drawing the circle that goes through the point 0, 2, what do you know about the radius of this circle?
1.
It's what?
1 would be the radius.
No.
2, because it's a 4.
It'd be 2, because this circle is going to be centered at 0, 0 if you watch the slope field there. And so this is going to be a circle with a radius of 2 is what we're looking at here. Okay. Now, to draw this, well, you know, give it your best shot. And the idea is you should be kind of following the direction of the slope field. You know, not perfect, but you get the idea there.
It's a square with rounded edges.
A square with rounded edges, you know. Now, what is the equation for this solution curve? And I don't have in my notes that I went back up and solved it. Not that we couldn't, but do you guys remember just the equation of a circle?
2, no. 1/2 pi r squared. No.
No, not a formula of how to find area or circumference or...
Just circle. 1/3
Circle.
circle. 2 pi, 2 pi r.
No pi.
2 r squared.
1/3 h r.
Okay, so we don't remember. Got it. Okay. Back, I don't know, at some point we've talked that the basic equation of a circle,
Oh yeah.
x squared plus y squared equals r squared. That relates back to our ellipses from last year, if you recall the ellipses. Okay, that were x squared plus y squared, or officially it was x squared over a squared plus y squared over b squared equals 1. Okay, this is the variation of it without the denominators. So in this equation, what would we have? X squared plus y squared equals
4.
4. Okay. If you solve that for y, what is it going to be if you solve it for y?
4 minus x squared. Our square root of
Square root of 4 minus x squared, the square root of 4 minus x squared, and what can you not forget?
plus or minus.
Plus or minus. Okay. Remember, the plus or minus, the plus is going to give you the top half of the circle. The negative is going to give you the bottom half of the circle. Okay. Now, if we wanted to, they originally gave us a differential equation, dy dx equals negative x over y. We could have gone up and, separated our x's and y's and integrated that just as well too. But I was trying to go with just, what's the equation of a circle? Now, I believe on the next page, G and H go along with this. Okay. So G asks, explain what happens to the slope values as you move from left to right with a fixed value. Okay. So explain what happens to the slope as you move from left to right with a fixed y value. So a fixed y value is going to be a horizontal, yes? Okay. So what's happening to our slope values as we move from left to right? What'd you say?
Increasing to decreasing.
Okay. So officially, I agree or disagree with that?
It's decreasing. Then increasing.
So over,
No,
the negatives always throw me
just
off.
It's just decreasing. What? Just decreasing.
Okay. So, let's figure this out. Okay, so if we start over here, and I'm picking this row right here to look at. We can pick any row to look at, but okay, so what's happening here? This was positive 1/3, or no, positive 3. Positive 3, positive 2, positive 1, 0. And then we have what? Negative 1, negative 2, negative 3. So what did we do there? 3, 2, 1, 0, negative 1, negative 2, negative 3.
Yeah.
So those values what?
Decreased.
Decreased, yes? Now, is that true everywhere?
No.
What happens if we pick a row down here?
Increasing.
Okay. Now we're going negative 3, negative 2, negative 1, 0, 1, 2, 3. What's the difference?
It's the opposite.
Below the x-axis.
Yeah. It's based when y is positive, anything up top when y is greater than 0, or when anything is below, y is negative. Because, keep in mind, if you're using that original differential equation of dy dx equals negative x over y, it's a matter of what that y value does. Well, a positive y value versus a negative value is going to affect how this fraction reacts. Okay? So, what I have written in my notes is if y is greater than 0, dy dx decreases. If y is less than 0, then dy dx increases. And this is as you move from left to right. Okay? So, y is greater than 0. Then dy dx, that was increasing up there, right? No, decreasing. Y is less than 0. And dy dx increases. Okay. And explain what happens to the slope values as you move up from the x-axis with a fixed value of x. So kind of like with the y's, I was just picking a horizontal and going. Now with the x's, we're going to pick a vertical. Okay. It says as you move up from the x-axis. Now at the x-axis, what do we know about the slope? It was undefined, right? Undefined, non-existent, no slope, whatever. But other than that, what happens as we move up? It's like if I'm picking the 1 column here. What do we have here? We have negative 1, negative 1/2, negative 1/3.
The slope gets less.
Decreases.
Yeah.
And you could check over here in this quadrant over here. I like to check different quadrants. So here we're at positive 1, 1/2, 1/3. Okay. So yeah, dy dx is undefined at the x-axis, but otherwise it decreases as you move up. So. I'm going to write that real quick. That's undefined at the x-axis Um, and it decreases as you move up. Okay. How do we feel about matching? Okay. So example 4 is matching. And you've got A through H and 1 through 8 that we've got to try and match up. Now, keep in mind, I know it's been 2 days now, but, we talked on like Monday when we did example 1. Example 1 was just depend on the X value and what happened there. You kind of watch certain columns or rows. So, take a gander. And see if you can come up with any guesses. Got any starting matches? A starting match you want to throw out and see what we think?
Is 2G.
Is 2G? Is that what you said?
Yeah.
No.
Is 4C.
No.
It's 4H.
H.
I could go with 4 as H.
Is 1A.
No. Okay, pause.
3C.
4H. The question was, is 4H? And I agreed to that one. A couple of you had 4 as H. Why?
Because
Okay. Now, keep in mind, this is the differential equation, right? And as we look at the slope field, now technically, what I would have said, so like if I watch right here and I kind of trace, which curve is it that goes through 0, 0? Okay. Or that, so technically what you're looking at right here is a sine curve. But again, you're talking differential here, right? Okay, so like if we solve that, the integral of cosine is going to be sine. Okay. So that is one technique to help, is if you can recognize a graph. Okay.
What about 6A?
6C.
I'm thinking 6C.
I could go with 6C.
Nice. Because it could be a cubic.
Huh?
Be a cubic.
Okay, so you guys are trying to match shapes is what you're trying to do.
Yeah.
Okay. I've got some other ideas for you too, but okay. So 6C, he's saying could be a cubic. So like when you integrate, here's what I would look at. In this particular differential equation, notice there is no x value, yes? Okay. If there is no x value, then that means your slope is only going to depend on the y value. If you notice here, if it only depends on the y value, my horizontals are all the same all the way across. In other words, like right here at when y is 0, that would be 0 squared plus 1. and it looks like a slope of 1. As you move up, the bigger it gets, notice what's happening. The more vertical it's getting, right? Down below, you kind of have the same thing going. The farther you get, the farther away you get, or the bigger y values you get, the steeper my slope gets. Okay, so the fact on C that there's no x and the y's are consistent, okay, like each y value is consistent, that tells me I'm looking for something without an x in it. Okay, so that's a technique to look for.
Natural log has to be positive, doesn't it?
It does.
So 5e.
I believe so. Are you guys with them?
E.
5, you have to plug into natural log. You can't plug a y value into a natural log that's negative. So y cannot be negative. What are you noticing down here? The slope field doesn't exist when y is negative. So what this one tells me is that y must be greater than 0, and that's a natural log thing. Okay? Can you figure out what's going on in D?
There's an E.
Like on E, y couldn't be negative, right? On D, x can't be some values over there, right? There's a cutoff value. We don't know what that value is, but there's a cutoff value of some sort.
2.
1.
Oh, negative square root.
Because what is this? This is going to be x has to be greater than negative 2, so that's probably the negative 2 value there. Okay. Now, we don't exactly know what value that is till we pair it up with an equation there. Okay.
Is 7F.
Is 7F? No.
That is the weirdest I've ever Sorry. Is 8F.
Is which one F?
8?
Yes.
Yeah.
Now why?
Because it's got kind of the same shape as the other cosine one.
Okay. You're seeing, now, and the difference is this is x plus y, so that kind of makes things,
Right.
I'm not exactly sure what this graph would look like. Okay. And here's something I like to do, guys. I like to just pick points, random points sometimes, and start plugging them in. Okay. That sometimes helps. I'm trying to think here. Where are we at? So, as we look at the ones left, notice 2 only has x's, 3 has x and y, 7 has x and y. Okay? So that can kind of lead to some help maybe. What have we not used? What are we down to?
A, B, and G.
A, B, and G. Okay.
Is A
2.
2? Yeah, that's one.
Mm-hmm.
Because
The Y's are
the
the
y's
same.
are all the same.
Right. Okay. On C, it was everything going across was the same because the y's all had to be the same because there was no x. On 2, or on A, there's no y. And if there's no y, then that means your x's are consistent. Okay, so now your x's being going up and down. Okay. I'm just trying to give you some various clues I found over the years that help.
Is 7B.
3G.
7 is B. Now, something I noticed on 7, which is helpful, if you look at each quadrant, it's kind of helpful because in each quadrant, like In quadrant 1, my slope is all negative. And the same thing is happening down in quadrant 4. My slope is negative. When I look at quadrant 3, I said that wrong. When I look at quadrants 2 and 4, my slopes are positive. Now, look at what was going on here. It's the negative of x times y. Well, in quadrant 1 and 3, we have same signs, right? Positive times positive, you'd have to have that negative. Negative times negative is a positive times a negative. Whereas in quadrants 2 and 4, you're multiplying a positive and a negative value. Okay? And there is something to be said for process of elimination, isn't there? Okay. 3 is G.
Because it looks like a cosine in the middle.
Okay, you're seeing the curvy shape in the middle. Trying to figure, I have written in mine on G, when y equals 0, the slope is x. I know, I'm trying to understand my own note to myself here. When y equals 0. Oh. Okay, so when y is 0, because sine of 0 would be 0, right? The slope is just x. And so I guess then when y is 0, the idea that the x values are increasing and decreasing appropriately. So, okay. Plugging specific points in. I don't know that we did much of that, but that's kind of the idea that I was leaning towards up here with B, that, you know, if you pick some points and just plug them in, that will, you know, sometimes help. Take the x and y value, plug them in, you know, try and match it up that way. Okay? Okay. Moving on. Example 5. A differential equation, a point and a slope field are given. Use the slope field to sketch a particular solution through the point. Then, use integration to find the particular solution of the differential equation. Now, what they ask for? 0, 1. Any idea of what's going on here? What?
Wait, is there an asymptote like at -2?
There is. There is indeed some type of asymptote action happening at -2. Okay. And, you know, you're noticing that by the slopes getting, you know, steeper and steeper and steeper and hitting each other, you know, that there's got to be some, you know, moment when it turns around, and that's it. So can you visualize a graph on the right side there to draw? Tate's. Yeah, that's, I mean, the idea that it's going to have to run along this asymptote, right? And then it's going to curve and go through 1. It's hard to get along the, yeah. I don't know, something along that line. I'm not saying mine is great by any means, but you get the idea. Yeah, as I look at my notes, mine went a little bit higher in my notes, but do you remember what graph shape that looks like? Not exactly E.
Yeah.
It's the inverse of E.
Natural
log. Mm-hmm. Okay, guys. Let's solve this. In order to integrate, we need to separate our y and x. So dy is going to be equal to 1 over x plus 2 times dx. We're going to integrate. What's the integral of y? Excuse me. What's the integral of dy?
Why?
What's the integral of 1 over x plus 2?
Natural log of 2.
Natural log of what's in the denominator? X plus 2. Right? Because reverse it. What's the derivative of natural log of x plus 2? 1 over x plus 2, right? And that's something we've used substitution before a lot, right? So I could always go back and do use substitution. What, of course, do I have to include here? Plus c. Now, it did ask us to find the particular solution. Okay, so we're not supposed to stop there. They gave us an ordered pair, yes? In an ordered pair, this is xy. Plug those values in to find c. So 1 equals natural log of 0 plus 2 plus c. Okay. So 1 equals the natural log of 2 plus c. Notice I dropped the absolute value. Once you know that, you don't have to write it. What is c going to be? 1 minus the natural log of 2, unless we're using a calculator. Okay, there's no indicator here that we are. So rewrite your y equation. What is y now?
Natural log of x plus 2 plus 1 minus x log of 2.
Okay. Natural log of x plus 2 plus 1 minus natural log of 2. There's your equation. The idea is if you graph that equation, you should get that type of graph. Okay. Last thing, what strategies and trends do you look for when matching slope fields? Okay, so this is just kind of summarizing up some of the things that we talked about. You guys want to throw any thoughts out, or?
Shapes.
Okay, looking at the shapes as to, you know, if you can figure out an integral in there. I guess I need to advance my screen, yes.
Looking at the x and y values.
Okay, looking at x and y values, whether it be like picking a specific point, or a good technique that often works is if there's just x or just y, right? Looking at how those are going to change.
Where it's at. So like on the other ones there wasn't any.
Oh, when the graph was non-existent. And that would be looking at the idea of when, you know, when that x value doesn't exist or that y value doesn't exist. But also I was going to go along that same line, looking at where the slope is 0, where the slope is undefined. Okay, because those are values that can help us there. So, okay. We've kind of, you know, in some way or form we've talked about a lot of the things I have written here. So, let's see. How do I write? If, let's see. If dy dx has x, then realize your slope, well, the way I have this written is your slope changes from left to right only. Okay. So then if dy dx has y, then we can talk about the slope changes up and down only. dy dx has both x and y. Realize the slope's going to change in both directions. Okay, kind of like I did with that, the one with the 4 quadrants towards the end about where slope was positive or negative. Find what conditions will make dy dx less than 0 or greater than 0. Find what conditions will make dy dx less than 0 or dy dx greater than 0. Then I have written down where is dy dx equals 0 or undefined. Okay, and then I have 6 on mine that is just check, you get desperate, just pick a point, like pick 1, 1. Plug 1, 1 in, see what happens. See if you get a slope that could be that same thing. So I have 6 on here that's check specific points in each quadrant. Okay. And you can add things on the side that, are important to you and whatnot. Okay. Okay. Try to remember exactly how this homework works. So, 1 through 6 says to draw slope fields for the following differential equations. Okay. Now, okay, that's why. Okay, so 1 through 6 says draw slope fields for the following differential equations. Yes? Now, go read the directions on 7 through 12. Solve each differential equation to find the particular solution from initial conditions. Then sketch the particular solution on the slope field for questions 1 through 6 for each equation in questions 7 through 12. So 7 through 12 match up with 1 through 6 is what we're saying. Okay? So like when you solve 7, 7, the differential equation for 7 is going to match with the slope field for 1. Okay? So, see what you can do with these. You've got another matching section.
So like on 7 through 12, we take the derivative and then plug in the point to get C.
Take the integral.
Yeah, that's what
Yeah. So on 7 through 12, you're basically doing what I just did here. Okay? Where you are moving the dx over. I think most of the time that's all you'll, except putting x's on one side, y's on the other side. And then using that point to find C. Which we talk about more, lesson 7.3 is where we really talk about separation of variables and how to solve these. But they go ahead and throw it in 7.2. Okay? So, see what you can do with that. I would say it's only 3 pages, but slope fields are not a quick thing for me to do. I don't know about you guys, but